channel. So in this session, let us have a look on the concept structures. So coming to the previous sessions, we have seen what is a variable, and in order to declare a variable we require one data type, and after that, so any variable can store only a single value at a time. So if you want to store or update that variable, the value will be replaced. So if it is a normal variable, and after that we have seen arrays. So that means storing of multiple elements of same data type. So under the similar name, same name. So a single name will be there, and we can store multiple number of elements of same data type. So that we call it as array. And now the structures is, it is also a collection of elements with different data types. So in this, by using this structure, we can have a single name, and under this single name we can save multiple number of elements with different data types. So for that, first of all, we have to create a structure. So that means we have to define a structure with a multiple number of elements. So here we call them as a members of a structure. So in the array we call them as elements, whereas in the structure we call them as a members. So first we have to define a structure with different members, and then by using that structure we have to declare the structure variables. So here we are seeing that structure variables. That means that particular structure variable will be having all the access to all the members of the given structure. So let us write that so that you can clearly understand. First we have to define a structure, and then declare structure variable, and then initialize members of structure, and then accessing the members of structure variable, members of a structure. So these are the steps we need to follow if we want to implement the structures. First we have to define a structures with multiple data elements, that we call it as a members, and then we have to declare a structure variable, and then initialize the members of a structure and access the members of a structure. So first, coming to the defining a structure. So here we will use a keyword struct. So the syntax for define is use the keyword struct. Struct tag name. So tag name is a structure name. So we have to give one name to the structure. So that name can be anything other than the keywords. So this is also just like our variables. We have to follow the rules to be which we are following while creating a variable. The same rules to be followed while creating the structure tag name. So struct tag name, open brace, write on the members, list of members. So data type, variable name, again data type, variable name, etc. Close the structure, and then put the semicolon. Close the structure and put the semicolon. This is the important for declaring a structure, defining a structure. So here we didn't declare any structure variable, just we are defining a structure. So our next step is declaration of structure variables. So the structure variables are declared with the help of the tag name. So by using the reference of as a tag name, we have to declare structure variables. So here we have seen a normal variable which holds the value and a pointer variable which holds the address, and here we are seeing the structure variables which are having the access to all the members of a given structure. So here this tag name is optional. This tag name is optional. So that means without using this tag name we can create a structure. But all the structure variables should be declared in this definition itself. So here instead of writing the semicolon, you have to declare structure variable. Structure variable 1, structure variable 2, and so on. Close the semicolon, means use the semicolon. So without using this tag name we can create a structure, but every structure variable can be declared in the definition itself. And if you write the tag name, then we can declare n number of structure variables in the program where we need, where we require. So then once again we need not write the structure, just we are using this tag name and we are declaring the variables in the program. So if we are not writing this tag name, all the structure variables should be declared in the definition itself. So let us see an example so that you can clearly get it. See, struct, let us declare or let us define a structure for a student. Struct student. So I am giving the tag name as a student. So in the student there are different members. That means there is a name, ID, and let us take a percentage. Integer ID, semicolon, character, name of 20. So here name is a string and a string must be implemented by using character arrays. So I have created an array. Then float percentage. Close the braces and close the semicolon. So here we are not declaring any variable, structure variable. So in this case, if you want to declare a structure variable, we have to use this tag name. So this is the structure definition, and if you want to declare a structure variable, struct student, so we have to use this variable s1 semicolon. So that means s1 is a structure variable which should follow the structure of student. So that means s1 will be having ID, name, and percentage, because we have written all these three members in the structure with a student tag name. So here we are declaring one structure variable which should follow the structure of a student. That means all the structure variables will be having all the data members of structure. So they can access the members of a structure. So student 1 will be having ID, name, and percentage. If you want to declare one more variable, just use the comma operator and write s2. So here this statement means we are declaring two structure variables s1 and s2 which should follow the structure of a student. Then second one, struct int ID, character name of 20, float percentage. So in this case we are not writing the tag name. So whatever the variables we require in the program should be declared here itself, in the definition itself. So S1 comma S2. So the meaning is same for both the cases. So here also we have declared two structure variables which will follow the structure. So here we are not giving any tag name. So here we are giving the tag name. With the use of tag name we are declaring the structures. So after some executable statements, if you want to declare one more structure, we can declare here. But in this case, we cannot declare the structure in the further concepts, further code. So at the definition itself, we have to create the structure variables. And here also, S1 will be having ID, name, percentage. S2 is also having ID, name and percentage. So this is the definition of a structure and this is the declaration of a structure. Now, what is the initialization? How we have to initialize the structure variable? And before going to that, where we have to write this structure? So we can write this structure anywhere in the program. So we can write this structure outside the main function, and all the structure variables can be declared inside the main function. Or we can write the structure definition inside the main function, and declaration can also be done in the main function. So anywhere in the program we can declare or we can define the structure. So next, how to initialize the structure variables? Here be careful, structure variable means the three members. So here the structure variable S1 implies S1, ID of S1, name of S1 and percentage of S1. So we have to initialize each structure variable. So for initializing the structure variable, simply we can write it as, so here we have seen the initialization in two ways. One is compile time initialization and another one is runtime initialization. So for the runtime initialization, we will initialize the structure variables using the scanf function. That we know that. So in the compile time initialization, we will use some assignment operator, that is equal to. So struct student S1 is equal to, open the curly brace, write down all these things. ID, we have to initialize the ID as 20, comma, name is a string. So a string must be represented in double quotations. So double quotes A, B, C, let us take a name, comma, percentage, it's a float, 75.5, close the brace, close the semicolon. So this is the initialization, direct initialization, that means a compile time initialization for a structure variable S1. If you want to initialize the structure variable S2, again write this. So again we have to write in the next statement, struct student S2 is equal to 30 XYZ 78.4. So this is the initialization of a structure variable. So here the structure variable means it will be having the members of structure. Every structure variable will be having the members, all the members which are defined in the structure. Now, how to access the structure, the members of a structure by the structure variable? How to access them? So here we are saying that S1 is having ID, name and percentage. Similarly, S2 is also having ID, name and percentage. So how to access the members by the structure variable? So this accessing can be done by using dot operator. That means dot operator. So by using the dot operator, every structure variable will access its members. So if S1 wants to access the ID, that representation will be S1 dot ID. if S1 access the name, it will be written as S1 dot name. If S1 want to access the percentage, it will be written as S1 dot percentage. So by using this dot operator, the members of a structures will be accessed by the structure variables. So this is the direct initialization, or simply by using these accessing also we can declare S1 dot ID is equal to 20, S1 dot name is equal to. So this direct initialization can't be done in the strings, right? So for this we have to use the same structure variable, or we can use the pointer and then we can directly initialize a name to the character arrays. So like this simple initialization also we can assign the values to the members of a structure variable. And now let us see the runtime initialization. So runtime initialization is also similar. By using the scanf we will initialize the values. So for that, if you want to initialize this S1 variable at the runtime, so scanf, it is a percentage, it is integer data type, percentage D. Next, name. So we can use percentage S for reading the name. Next, float, it's a percentage F, comma, first one, ID. So ID means here we have to access using S1 dot ID, comma, S1 dot name, comma, S1 dot percentage. So this is the runtime initialization of a structure variable. Similarly, if you want to initialize the S2, write down S2.id, S2.name and S2.percentage. And all the remaining operations can be used by using this dot operator. So that means comparisons can be done, or any additions can be done, any manipulations can be done, any calculations can be done. So that will be done by using this dot operator. So the members of a structure variable can be accessed only through the dot operator. If you want to access simply ID, it is an invalid, because here the ID is a member of a structure. So this member should be accessed only through the dot operator by using the structure variable. So you can't write ampersand ID, because ID is a member of a structure. So ampersand S1 dot ID. So sorry, here I have to use the ampersand symbol. So as it is a string, we need not use the ampersand. So scanf, percentage D, percentage S, percentage F, ampersand S1 dot ID, S1 dot name, ampersand S1 dot percentage. So hope you understood this one. So let us write a simple program to read, that means to read the data in the runtime and to print the same data. So the same, we have to write the printf statement, we have to erase this ampersand symbols. So let us see that. So the important point to be remembered in this structure is for accessing, so we can't directly access the members of a structure. In order to access the members of a structure, we require a structure variable and a dot operator. So only by means of structure variable and dot operator we can access the members of every structure. So this structure, and one more important thing is, we can define this structure anywhere in the program. And so even in the outside the main function also we can define this structure, and all the structure variables can be declared inside the main function. So let us write the program. Let us declare this structure outside the main function. Struct student, similarly int ID, character, name of 20, float, percentage. So just I have declared a structure, but the structure variables are not declared. Now write down the main function. Main, first declare the structure variables. Struct, use the student tag name. for declaring the structure variables student S1. Just let us declare only one function. Next, let us see that both the direct and runtime initializations. So let us use this S1. So ID is 10, name is ABC, percentage is 78.5. This is the compile time initialization. Once again, let us declare one more variable student S2. So let us initialize the members using scanf function here. So printf, enter the details of S2. So scanf. So in order to access the members, we need the structure variable and a dot operator. So percentage %b, percentage %s, percentage %f, comma s2 dot id, comma ampersand s2 dot id, s2 dot name, comma ampersand s2 dot percentage. And if you want to print the same, write down printf details of student 1. Printf student ID is equal to percentage %d slash t. I am using the vertical tab. Student name is equal to percentage %s, vertical tab, and student percentage is equal to percentage %f, close. Then write down s1 dot id, s1 dot name, s1 dot percentage. This will display the details of student 1. Similarly, same printf details of student 2. So again printf s2 dot id is equal to percentage %d slash t, s2 dot name is equal to percentage %s slash t, s2 dot name percentage, s2 dot percentage is equal to percentage %f, comma s1 dot id, s2 dot id, s2 dot name, s2 dot percentage. So this close the program. So this statement will display the details of student 2. So the 2 points should be remembered. One is the structure can be declared anywhere in the program, so it can be declared even outside the main function, and the structure variables will be declared inside the main function, and the structure tag name is an optional thing. So in order to declare more number of structure variables in the program, we have to use the tag name. And to access the members of a structure, we require the structure variable and the dot operator. So by using the structure variable and dot operator only, we can access the members of a structure, given structure. So here, how much memory it is allocated for a structure variable. So if you write int a, it implies, depends upon the compiler, 2 bytes will be allocated for a. Now here s1 is a structure variable, right? S1 is a structure variable. So how much memory it will be occupied? So S1 will be having, so we are declaring the structure variable, that means it will follow the structure of student. So what is the structure of student? ID, name and percentage. So we have to add all the memory spaces occupied by these members. So for int ID, it requires 2 bytes. And for name, as it is a character 1 byte, and here we are declaring an array with 20 elements, so it requires 20 bytes. And coming to this percentage, it's a float, it requires 4 bytes. So total 2 plus 20 plus 4, that means 26 bytes. So the structure variable, in this example, the structure variable S1 and S2 will occupy 26 bytes of memory, because S1 will having all the 3 members, as well as S2 is also having all these 3 members. So we have to add the memory occupied by all the members of the structure. So by adding all the sizes of members, we'll get the memory occupied by the structure variable S1. So here 26 bytes will be occupied by structure variable, which is created by using a tag name student. So S1, here in this example 2 structure variables are created, so S1 and S2 both occupies both 26 bytes of memory. S1 will occupy the 26 bytes of memory, and S2 will also occupy the 26 bytes of memory. So let us stop here in the today's session, and if you like my videos, share my videos with your friends, and do subscribe to my channel for getting more videos on the C programming and other technical concepts. And if you are having any doubts, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And thanks for listening to my sessions. Thank you very much.